In this video, we're going to have a look at how we find the solution to simultaneous equations by using a method that's known as substitution. Now, I think this method is the most robust and most useful method to learn when we're solving simultaneous equations. So here, I've got two equations written that I want to find where the point of intersection essentially are on the graph of these equations. So to help us refer to these equations in this video, I'm going to call the first equation, equation 1, and the second equation, equation 2. Now when we're solving simultaneous equations, what we're essentially trying to do is try and find where are the y and x values in equation 1 the same as the y and x values in equation 2. So what that's saying is we're looking at where is this y value the same as this y value. So if we've got in one of our equations the y value isolated, we can actually substitute this into the other equation. And that's what we're going to do. We're going to substitute equation 1 into equation 2. Now before we do this, it's important to note that we're looking for the solution where the x values are also the same. So if you've got an equation where the x value is isolated, you can also substitute that one into the other equation. But let's take a look at what happens when I substitute this. So I take equation 2 and wherever I see the y value, I replace it with x plus 2. So equation 2 is 2x plus 3y. In this case, I'm replacing or substituting the y for x plus 2 is equal to 16. And what you'll now notice is I've got an equation where I've eliminated all the y values. So what that means is I can find a solution for the x value now. So next I expand this. So this will be 2x plus 3x plus 6 equals 16. I then simplify this side. 2x plus 3x is 5x plus 6 will equal 16. And now I solve for x by subtracting 6 from both sides. So 5x will equal 10. Now I divide both sides by 5, finding my x value of 2. But remember, we're looking for both the x value and the y value when these two lines are intersecting each other. So to do that, what I actually do is I substitute this x equals 2 into either one of these equations. I'm going to use equation 1 because that's going to be simpler to do. So I substitute x equals 2 into equation 1. So equation 1 was y equals our x value of 2 plus 2. Therefore, our y will equal 4. So we're proposing here that the solution where these two lines intersect with each other is where the x value is equal to 2 and the y value is equal to 4. The advantage of this problem though is we can actually check it. We should be able to substitute our values of x equals 2 and y equals 4 into each one of these equations and they should balance. So let's do a check step. First, equation 1, where y equals x plus 2. We're saying y equals 4 and x equals 2. Let's solve the right hand side now, where 2 plus 2 does equal 4, so it works for equation 1. What about equation 2? Well, equation 2 said 2x plus 3y equals 16. Well, our x value we're saying is 2, and our y value we're saying is 4, which should equal 16. 2 times 2 is 4. 3 times 4 is 12, and that should still equal 16. 4 plus 12 does equal 16, so we've found a correct solution for the second equation. So our check step has verified that we've found the correct solution here. So therefore, our solution is x equals 2 and y equals 4. And this is how we use substitution to find the solution for simultaneous equations. But let's take a look at the bicycle problem that we had in our previous video. So in our previous video, we discovered that our cycling puzzle can be represented by the following two equations, and the correct solution to the puzzle was the point of intersection on that graph. Let's use our substitution now to find that solution. So to help us here, I'm going to number the equations, equation 1 and equation 2, so I can refer to them in the video. Now, you might immediately notice that unlike our previous problem, we don't have an x equals or a y equals anymore in one of our equations. So what that means is our first step actually has to be to take one of these equations and isolate the x or the y value. Now, it's going to be easiest to work with equation 1. So I'm going to use equation 1, x plus y equals 11, and isolate either the x or the y. In this case, I'm going to choose to isolate the x value. To do that, I subtract y from both sides. So on the left-hand side, it will leave me with x. On the right-hand side, it will be 11 subtract y. So what I've done here is I've successfully isolated one of the variables. And for the purpose of this video, I'm going to call this equation 3. So now what I need to do is I need to take one of the equations and substitute it back into the other. Now remember, equation 3 is actually equation 1. So we need to substitute this into equation 2. When I do that, I need to substitute or replace my x value whenever I see it with 11 subtract y. So equation 2 is 2 multiplied by x, so our 11 subtract y, plus 3y equals 25. I then expand this side, so it will be 22, subtract 2y, plus 3y equals 25. I simplify this side, so negative 2y plus 3y will be 1y, or just plus y, equals 25. Then I solve for y by subtracting 22 from both sides, so therefore my y value will be 3. Once I've found this, I substitute my y equals 3 back into one of the first two equations. I'm going to choose equation 1. When I do that, I've got x plus my y, which is 3, which is equal to 11. So when I solve for x, I find that that equals 8. So what I'm proposing here is the solution is x equals 8, y equals 3. But remember, we can check our solution when we're using substitution. So let's do that now. So we start by checking equation 1, which was x plus y equals 11. Our x value should be 8 plus our y value of 3, which should equal 11. 8 plus 3 does equal 11. So it works for equation 1. What about equation 2? Equation 2 was 2x plus 3y equals 25. Our x value, so 2 times our x value of 8 plus 3 times our y value of 3 should equal 25. 2 times 8 is 16. 3 times 3 is 9. 16 plus 9 should equal 25. It does equal 25. So we've found ourselves the correct solution. So our check step has verified that the x value and y value that we found is the solution to both equations. But what does that mean in terms of our problem? Well, our x represents the number of bicycles and our y represents the number of tricycles. So therefore, there are 8 bicycles and 3 tricycles in the display window, which we know to be true from our previous video. So what are the benefits of substitution? Well, the main benefit is this. Substitution will find the most accurate solution no matter what type of simultaneous linear equations that you end up with. So for really complex problems that don't give nice, easy solutions, whole number sort of solutions, substitution is the most accurate method to use. Another side benefit of substitution is you can actually check to make sure that you've got the correct solution. So far we've covered trial and error, graphical solution, and substitution. There is one other method that we can try, and that's by elimination, which we'll cover in our next video.